Hey students, this is going to be the second type of difference analysis, namely the paired samples t-test. And as you know from class, the paired samples t-test is used to look at how a group of respondents, without differentiating between subgroups, just a sample of respondents, answers on certain questions. And more specifically, whether there is a difference in how they answer to two metric scaled questions. So let me show you by means of an example. Let's say we want to know how our sample here in this craft beer dataset answers on average to the question craft beer enthusiasm, which carries the label I consider myself a craft beer enthusiast on a scale from 1 to 5. And we want to compare that with how they answer to the subjective knowledge question, which is actually that index that we created based on those 6 separate subjective knowledge questions in an earlier video, also on a scale from 1 to 5. So what we want to do is compare the answers, the average answer on this metric scale question with the answers on this metric scaled question for our whole sample. And this we do by means of a paired samples t-test. So we go to Analyze, we click Compare Means, because after all what we're doing is comparing means. Whoops. And then we go to Paired Samples t-test. When we click Paired Samples t-test, this window opens up. You can of course drag it to wherever you want on your screen, and we can make it a little larger. And now on the left side, what we're going to do is we're going to select the two variables that we want to compare. Let's find the lifestyle I consider myself a craft beer enthusiast question. So we click on it and click it in. It appears here as variable 1 for the first pair. We're only doing one pair now. Second variable we want is that computed index of subjective knowledge, which is that like combined or computed version of those 6 small subjective knowledge questions. So we click that one in, and when we enter that, it shows up as variable 2. Cool, this is all there is to it. We have variable 1 and variable 2, and we want to compare these two. See if there's a significant difference between how people answer on this one versus how people answer on this one. So we hit OK, and this is what our output shows us. The first table gives us our sample statistics for this variable and for this variable. So for this variable, we see that the average is 3.15 on a 5-point scale. Now for this variable, subjective knowledge, we see that the average is 3.35. Again, with the naked eye, we would think, yes, there's clearly a difference. It seems like this one is a little higher. But again, we do not rely on that. We actually go down and look at our paired samples t-test results. So here you see for the pair lifestyle, I consider myself a craft beer enthusiast, and the computed subjective knowledge index, which consists of these 6 sub-questions, we see that the significance two-tailed is 0.002. What this means is, since this value is smaller than 0.05, it means there is a significant difference between the answers, the average answer on variable 1 and variable 2. Specifically, we could say that people on average think they have a higher subjective knowledge than that they think they're craft beer enthusiasts. So the score on subjective knowledge in our sample is significantly higher than the score on craft beer enthusiasm. We could have come to that same conclusion by looking at our t-value. Remember, t-value is nothing more than the same as a z-score we would calculate with a formula. So what we use here is the benchmark 1.96. Now in absolute values, this one, 3.139, is larger than 1.96. Remember, absolute values, because minus 1.96 on the left side plus 1.96 on the right side. This one is minus 3.13. So this means it falls outside of the confidence interval on the left side. It is lower than minus 1.96. So that confirms that we cannot support a null hypothesis. so we reject the null hypothesis, and so we go for the alternative hypothesis, which states that there is a significant difference between our two variables that we are comparing. So as you can see from this test, which is a fairly easy test, these will never contradict each other. You use the benchmark 1.96 for your t-score, and you use the benchmark 0.05 for your significance value two-tailed. Conclusion is that we did find a significant difference between the average score of our sample on craft beer enthusiasm versus the average score on subjective knowledge. And that's all there is to it with the paired samples t-tests.